Hello everyone. So this is Professor Nisar Sheikh. In this video, we are going to see there are different 100 MCQs on our engineering graphics and CAD subject. Okay. So whatever these our MCQs are there, so it will be on the our different chapters like projection of planes, projection of planes, projection of solids, orthographic projection, and the section of solid. Okay. So we'll start it one by one. So let us see. So first one is the projection line is okay. Now, so whatever the projection line. So first of all, so there are the different options are there like continuous thick line, continuous thin line, chain thin line, dashed line. Okay. So first of all, we need to understand. So what is mean by the projection line? Then you will able to then you will able to tell uh, what is mean by or how it will be the projection line. Suppose in the example, suppose this is the xy line. Okay, here is the point A. Its front view is the A dash, and suppose its top view is the A is there. Okay. Now, so what are the front view and the top view of this point A? Okay, so it will lies. Okay, so it will lies on the same projector. So like this. Okay, this here. So whatever this projector is there. Okay, so you can call this line as a projection line. Okay, now suppose if I want to draw the locus from this point A, then so it will be like this. Suppose I want to draw the locus from the A dash, so it will be like this. Okay, so here, so all these locus lines or these projectors are there. So these are the projection lines are there. And in case of these problems, so what are these lines are there? So we are showing it by the faint lines. That means we are showing it by the continuous thin lines. Okay, means here. So our, so which option so it will correct? So continuous thin line. So we can call it as also a faint line also. Okay. Here are the different options. So continuous thick line. So it will not possible because continuous thick line. So we are using it for the visible outline of the edge. Okay, so chain line, chain thin line, so it will not possible because for the axis we are using chain line. So dashed line, so it will not possible because for hidden content, for showing hidden content we are using the dashed line. So that's why the option B will be correct, the continuous thin line. Okay, then next, now visible outline or the edge. Okay, now here, so the different options are there. So continuous thick line, then continuous thin line, chain thin line, the dashed line. Okay, so which option so it will be correct? Because we are knowing that so whatever the visible edges, okay, or the outlines are there, so that we are showing by using the continuous thick line. For example, suppose I'll take here one example. Suppose suppose one object is there. Okay. Suppose this is the 3-dimension object. Okay. Now, so when you observe from the front side, suppose I want to draw the front view of this object, then which edges? So it will be visible from this side. Okay. So you can see, observe from this side. So I will able to see this edge. Okay. So then this edge, so it will be visible. Then this edge, so it will be visible. Then this also visible. This here in shortly. So whatever these visible edges are there, so that we are showing it by the continuous thick line. So sometimes we can call it as also dark lines in while drawing its views. Okay, this here. whatever these visible edges are there, so these edges are there, so we are going to draw it by using the continuous thick line. Okay, now suppose visible outline means what? We'll take one more example. Now suppose I'll consider the one cylinder is there, suppose. Okay, suppose this is the cylinder. Okay, now so while drawing its front view, okay, so how it will come, so we'll check out it. Okay, this is the cylinder, and suppose now I have to draw its front view from this direction. Okay, now like this, so here, so in case of this rectangular block, so we're able to see these edges, so that's why we can draw it by using this thick line. Okay, but here, so what will be visible? Because in case of this uh, uh, cylinder, so edges will not be there. Okay, but whatever the outline definitely will be there. Then whatever its outline is there, so that we are going to draw by using the thick line. Because if you uh, observe from this side, okay, then in case of the cylinder, so you will get an rectangle, okay, as a front view. Means if you observe from this side, so you may get an like this rectangle. Okay, means whatever these edges are there, okay, means this one or the this one, okay, or the this one is here. So whatever these thick lines I have drawn here, okay, so it indicate the outline of this object. Means in shortly, how we can summarize, means whatever these visible outlines or the edges are shown by using the continuous thick line. So that's why here option A will be the correct. So that's it about this second one. So we'll see now next one. Next one, center line. Okay, so center line, so we can call it as, also we are calling it as a axis line also. Okay, so what is the center line? So how it will be, so by using this long, then short, this long short. Okay, so we are showing this center line. Okay, and whatever this center line is there, okay, so is there, so we are drawing it by the chain thin line. Okay, so that's why, so here option, so C will be the here correct. Getting it? The center lines are there, so that we are going to draw by using the chain thin line. So here, so option A, so where no, so it will not correct, because so where seam, so when we are using continuous thick line, so it's not possible continuous thin line, because so it's used for the projection line. So dashed lines is also not possible, because it's we are using it for the showing its hidden content. Okay, so that's the option C will be correct. Now next, fourth one, the following is not included in the title block of the drawing. Okay, so that we have to see. Now, sheet number, so it will be included. So in case of the title block, then scale also. So definitely it must be included. The scale means, so what are the drawing you are going to draw on the sheet, means what scale you are using, whether you are using 1:1, 1:2, etc. that you have to mention. Means 1:1 means what, whatever the scale or the whatever the scale you are using on drawing sheet. Okay, if it is as actual, so what the dimension or the size has been given on the object, then we are calling it as 1:1. Okay, if it is lesser than 1:2, 1:2 means such a scale, so it must be mentioned on the title block. Then method of projection. So method of projection means which method of projection you are going to use. It's a symbol, so it must be shown on the title. Means whether you are going to use the first angle method of projection or the third angle method of projection. Okay, it's symbol it must be mentioned. Then size of the sheet. Okay, size of the sheet, so it will not be mentioned uh, on the, or it is not included in the title block of the drawing sheet. So that's why here option, so D will be correct. Okay, so size of sheet, so it's not included. So fourth option will be correct. We'll see now next. Okay, which of the following represent the reducing scale? Okay, so which of the following will represent reducing scale? Now, so just in the previous MCQ, we little discussed about the scale, because suppose your scale is like 1:1, 1:1. So what does it mean? Means suppose, now suppose here suppose 10 millimeters. So one of the side is there, or the edge is there of the object. Okay, and on the drawing sheet also. Okay, on the drawing sheet also you are going to use 10 mm as it is, means 1:1. Okay, so at that time our current is 1:1. Okay, yes, it's not reducing, because what is our question? So which of the following represent the reducing scale? Okay, so it's not reducing because as actual, so we are using on the drawing sheet. Now second, 1:2. 1:2 means what? Suppose on our actual object, suppose 2 centimeter or the 2 millimeter is the dimension has been given. Okay, and for that, so if you are going to use 1 mm, okay, on the drawing sheet. Okay, at that time we can call it as a, or a scale as a 1:2. Is we have to check out. So is it matching to our question? So which of the following represent the reducing scale? Okay, is as actual, so it's not we are using on the our sheet, drawing sheet. And how it is, again it will see, so it is the reduced to 1. If it is it's given 2 mm on the object, but we are using 1 mm. Okay, so that's why scale is the 1:2. So that's why, so here our option B will be correct here, 1:2. Okay, so C 2:1, D 10:1. So these are not reducing scale. So here B option will be correct. Now next, the following line is used for the visible outlines. Already we have seen this, so just in the different way has been asked with this question, because we are knowing, so visible outlines are there. So for that we are using the continuous thick line. Okay, so option A will be correct here. Okay, then next we'll see. Okay, next, the following line is used for the dimension line. Okay, so we must know it, or already we have used in case of the uh, all type of the drawings, in case of the projection of line, projection of plane, in case of the orthographic projection. Okay, so whatever the line we are using for the dimension line, okay, so it must be the continuous thin line. So that's why here option B will be correct here, because faint line or the continuous thin line we are using for the dimension line. We are not using thick line, we are not using chain line, we are not using short zigzag thin line. So B option is correct. Then next, the dotted line represents. Okay, so many times, so I told about this dotted line. So when we are using the dotted line, okay, means something is not visible, means something anything edge or something content. Suppose it is not visible from the front side, top side, okay, or from the side view. Okay, then at that time, so what are that hidden edges are there? Okay, so that we are showing it by the dotted line. So that's why here option A will be correct. This dotted line represent the hidden edges. So other options, B projection line, it's not possible. C center line, not. Then D etching line, so it's not possible. So here option A will be the correct one. Then next, ninth, hatching lines are drawn at dash degree to the reference line. Okay, so as per the our BI standard, so Bureau of the Indian Standard. Okay, so we are using, or we are drawing hatching lens at an 45-degree angle to the reference line. So here option B will be correct. So this, so we need to remember because already we have drawn the hatching line. So in case of the orthographic projection, so whatever the sectional front view, sectional top view or the sectional side view, okay, if we want to show, then so in that case we have used the hatching lines, okay, and for that also we have used the angle 45 degree. Okay, so here option B will be the correct. Then next, the internal angle of the regular pentagon is dash dash degree. Okay, so first of all, we will see which is the internal angle. Suppose I will draw here pentagon. Suppose it's our pentagon. Okay, now this is the our internal angle. Okay, this is internal angle or included angle also we can call it as, and so it is the 108 degree in case of the regular pentagon. So we must remember. So that's why here option B will be correct. 108 degree. 72 is not possible. C 120 degree. So it's not possible because 120 degree is the internal angle of the regular hexagon. 150 degree. It's not correct. So here B option is the correct. So that is the 108 degree. Next we'll see. Okay, so next one is the 11th one, internal angle of the regular hexagon. So just in the previous ones I discussed, as we are using in case of regular pentagon, so 108 degree. In the same way, so in case of the regular hexagon, so we are using or whatever internal angle, so it will be 120 degree. Okay, so this also we have to remember. So you must know it. So the 120 degree. The next, so in third angle projection, the object is kept in. So its name itself indicate that third angle method of projection. So definitely, whatever the object is there, so we are going to kept in the third quadrant. So option C will be correct. So next, in third angle projection, so dash dash lies between the dash dash and the dash dash. Now, so we are aware that third angle, okay, in case of third angle method of projection, so whatever the object is there, okay, so it is placed in the third quadrant, okay, then so what are the plane of projection is there, so it comes between the object, okay, and the observer, means so this will the observer, so this will the plane of projection, and so here so our object will come. That means in case of the third angle method of projection, so here so plane of projection first of all come, okay, in between the our object and the observer. So accordingly we'll check out the option. So object projection plane observer, it's not possible because object set will not come between the projection plane and the observer. And second, projection plane comes between the object and observer. Here's the option, so B will be correct. Okay, this here, so projection plane, okay, so projection plane, so it comes between the object and the observer. So that's the option B will be correct here. Now next, 14th, in third angle method of projection, the front view will below the top view. So we'll just see something about this. So how it is in case of the first angle, in case of the third angle method of projection. So I'll draw here reference axis. Okay, so this is the xy. Okay, Now, in case of the third angle method of projection, okay. So whatever the front view is there, so it comes below the xy line. Means here, so our front view is there, okay. Then so whatever our top view is there, so it will come, okay, above the xy line, or above the front view, we can say. Then whatever its right hand side view is there, so it will come on the right hand side of the object, and whatever its left hand side view is there, so it will come on the left side of the object. Okay, so like this views will be there in case of the third angle method of projection. So so this will be the top view, so this will the front view, this will the right hand side view, okay, and this is the left hand side view. Means in case of the third angle method of projection, so top view comes above the front view, and whatever the right hand side view, so definitely it will be on the right hand side of the object, and whatever its left hand side view, so it will be on the left hand side of the front view. So these things we must remember, okay, or we must understand it. So now we'll come to our MCQ. Okay, in third angle method of projection, the front view will be below the top view. We'll check out here. So front view is below the top view. It's correct. So miss, if you check out here, so whatever the statement is there, so it's correct. Means our whatever the front view is there, so it comes below the top. So that's the option A will be correct. So it's true. Okay. So this is the answer. Okay, we'll see next one. Okay, 15th. In third angle method of projection, the positions of front view and top views are, so just we have seen. Okay, so positions of front to top view, so just we discussed. Isn't that what I was saying? So whatever our front view is there, so it comes below the top view, and whatever there is right hand side view, so it will be on the right hand side of the front view, and whatever it's left hand side view, so it will be on the left hand side of the front view. So that just we have seen. Okay, so here, so see it, it's in third angle method of projection. The positions of front view and the top views are. So we'll see the option. First, top view lies above the front view. Okay, top view lies above the front view. So as per third angle method of projection, so we are knowing that, so top view, so it lies definitely above the front view. So that's why here option, so A will be the correct. So B, so front view lies above the top view. It's wrong because it is in case of the first angle method of projection. Then next, front view, so lies left side of the top view. So it's not wrong. So it's the top view lies left side of to the front view. So it's also wrong. So here option, so A will be the correct. Okay. Regarding the third angle method of projection. Now next, in first angle projection, the object is kept in dash dash quadrant. So definitely it's again, so here also name itself indicate. So here first quadrant will be there in case of the first angle method of projection. Okay, we'll see the next one. In first angle projection is recommended by dash dash. Okay, so here, so we need to remember, so it is the BIS, Bureau of Indian Standard. Means in first angle method of projection, so it is the recommended by the Bureau of Indian Standard. Okay, then next, in first angle projection, the dash dash lies between the dash dash and dash dash. So just we will take a look over the how views will be in case of the first angle method of projection. So suppose this is the reference axis. xy and views. Okay, so in case of the first angle method of projection, so the how views will be, so that we have to see. Okay, but before that, so we'll see this one, because we are knowing, so whatever the in case of first angle method of projection, the object is kept in the first quadrant. Okay, so that's why, suppose this is the vertical plane, this is the horizontal plane. Okay, and here is the observer, and in between the plane of projection and the observer, so object is there. Okay, that means in case of first angle projection, the object lies, okay, object lies between the projection plane and the observer is here. So which option so it will be, so you can check out. So here what lies between the, so here object lies between the projection plane and the observer. So we'll check out option. So here this will be correct. Object, projection plane and the observer. Okay, so B option, projection plane, object, observer is not possible here, or option A is the correct, because we are knowing. So in case of first angle, object is lies between the observer and the projection plane. Okay, let's see the next one. In first angle projection, okay, the front view will be below the top view. Okay, so again, first of all, let us understand so how view will be there. So in case of the, suppose this is the axis, reference axis xy. Okay, we'll see how views will be there. Now in case of first angle method of projection, so whatever the front view is there, so it will always come above the xy. Then whatever is top view is there, so it comes below the xy. Then whatever is left hand side view, okay, left hand side view, so it will come, okay, on the right hand side of the object, and whatever is right hand side view, so it will come on the left side of the front view. Okay, so like this, so views will be there in case of the first angle method of projection. So these are the views. So this is the front view, this is the top view. So this is the left hand side view, so which is on the right hand side of the front view, and so this is the right hand side view, so which is on the left hand side of the front view. Okay, like these views are there. So we'll see, come to this one statement. So in the first angle projection, the front view will be below the top view. Okay, we can check out, so is it there? So this front view below the top view, it's not there, because top view is there below the front view. So here it's wrong statement, so it will be false. So here our option B will. Okay, now next, and in case of this we have to remember, so it's very important this, because in case of the first angle, it's left hand side view, so it comes on the right hand side of the object, so right hand side of the front view, and whatever is the right hand side view, so it comes on the left side of the front view. Okay, we'll see next one, 20th. And first angle of projection, the positions of front view and the top views are, so how will it be? Okay, we'll see. The top view lies above the front view. The top view lies above the front view. You can check out, is it correct? This top view lies below the front view. It's not wrong. The front view lies above the top view. This front view, it's above the top view. That means correct. So option B will be correct here. Then front view lies left side of the top view. It's not correct. Then top view lies left side to the front view. It's not also correct. So that's why here option B is correct, because as per this, so front view lies above the top view. Okay. We'll see next one. Okay, 21st. In first angle projection, the left side view will be on the left side of the front view. Okay, so just we have seen in the previous question. So how views will be there, because left hand side view of the any object in case of the first angle. Okay, so it will come on the right hand side of the front view. Okay, so that's why it's not possible. So this statement is the wrong. So that's why it's false. So your option B will be, because whatever the supposed statement, so it will be correct for in case of the third angle method of projection. Okay, means in case of third angle method of projection, whatever it's left hand side view, so it will come on the left hand side of the front view. Okay, so your B option is will be correct. The next 22nd, the positions of right hand side view and the front view of an object kept in first quadrant, the projection are drawn. Okay, so you see, so right hand side view is on the right hand side of the front view. It's not correct. It's because we are going to see in the first quadrant. Okay, missing related to the first angle method of projection. Then right hand side view is on the left side of the front view. It's correct. Okay, so B option will be correct. Then see right hand side view, so is above the front view. No, it's wrong. Then right hand side view is below the front view. So it's also wrong. So B option will be correct here, as per the first angle method of projection. Okay, we'll see next one. The positions of reference line and the top view in first angle projection are. Okay, so we are knowing now. We'll just check out the options. Okay, so here, so reference line lies above the top view. So just a little draw here, just it will be clear. So this is the reference line x1. Okay, and in first angle, this is the top view. Okay, so this is the top view, and this is the reference line. Okay, so we can able to tell here. So reference line, so we'll check out options. So reference line lies above the top view. Okay, so reference line, so this is the reference line. So is it correct or not? So we'll check out. So reference line, so here, so it is above the top view. This is whatever this first option is there, so it's correct. This reference line is there, so it is above the top view. That's why it's correct. We'll check out the other one. So B, reference line lies below the top view. Is it there? So this reference line below the top view, it's not there. It's wrong. Reference line left side of the top view, wrong. Reference line lie right side of the top view, wrong. So here option A is the correct, because here reference line lies above the top view. Okay. Then next we'll see 24. The position of the views with respect to a reference line will not change according to the quadrant in which the object may be situated. Okay, so we have to tell that, so that the statement is the true or the false. Okay. Now just to, for this we need to check out. So we suppose it will consider first quadrant. Okay, suppose object is kept in the first quadrant. So at that time, So whatever our front view is there is above the reference line. Okay, so this is the front view and top view below the reference line. Okay, and suppose object is kept, okay, in the third quadrant. If it is kept in the third quadrant, then how will be the views, this front view and top view? So we are knowing, so whatever our front view, top view is there, so it will be above the front view or above the xy line at the reference line, and this is the front view. Means it will check out. So what this statement tells, the position of the views with respect to the reference line will not change according to the quadrant in which the object may be situated. This statement tells that, so whatever the positions are there of the views, so will not change with respect to the reference line. Okay, so according to in which quadrant so that object is kept. Means suppose in suppose it is kept in the first quadrant. Okay, then whatever the front view is there, okay, so it comes above the xy line, above the reference line. Okay, and suppose the same object is kept in the third quadrant at that time, so front view, so it comes below the xy line. That means as per the location of the object, so in which quadrant we are going to keep it, according to that, so position changes. Means if you are going to keep it in the first quadrant, then at that time, so whatever the front view of the object, so it will be above the xy line. And suppose the same object you are going to keep in the third quadrant at that time, so whatever the front view, so it will come below the xy line. That means position is going to change. Getting it? That's why, so this statement, so is the false or the wrong. So that's why option B will be correct. Okay, so this is about the 24th. We'll see next one. Okay, the line formed by intersection of principal planes is called. Okay, because we are knowing that, so just tell you. Okay, suppose this is our vertical plane. Okay, suppose this is the VP and this is the HP. Okay, these are the two planes are there. This here, note the statement, the line formed by the intersection of the principal planes is called. Okay, so which is that line? So that will check line formed by intersection of principal planes. Means this is the VP and HP, these are the principal planes, and this is the line of the intersection of these two planes. Okay, and this line is there, so we are calling, because in case of the solution of the problems we are using this line, we are calling it as a reference line, so that we are doing it. So that's why your option D will be the correct reference line. Is the line formed by intersection of the principal planes is called as a reference line. So this will not be projection line, not origin line or the line of intersection. Okay, so this we are calling it as a the reference line. Next, the vertical plane is also called as. Okay, so this is our vertical plane. So it's another name. So as we are knowing that, so whatever our object is there, so in case of the first angle, so it will be hold here. Okay, then whatever its front view is there, so it will be will get on the this vertical plane. Okay, so that's why it is also called as a FRP, frontal reference plane, or it is also called as a frontal plane. So that's why the option C will be correct. So not straight line, straight plane, or the perpendicular plane, or the pole plane. So here option C will be the correct. Let's see next one. Okay. In orthographic projection, each projection view represent show how many. So it's actually represents. There's some uh, writing mistake. So projection view represents how many dimensions of an object. Okay, because we are knowing that. So whatever, suppose you will consider the front view of an object. Okay, so whatever the front view. So suppose this is a reference axis. This is the top view, and suppose this is the side view. Okay. Now, so whatever the front view is there, so this is the front view. Okay. So this is our side view. Front view, top view, and the side view. Okay. So here, so front view, so this is the combination of which two dimensions? Length and the height. So what is the top view? It gives the combination of length and the width. And the side view gives the combination of the width and the height. Means if you observe, so whatever the views we are getting from the orthographic projection, so that front view, top view, or the side view, it gives the only two dimensions. Okay. That dimension, if you consider front view, then it will give the length and height. If you consider top view, it will give the length and width. If you consider the side view, it will give the width and the height. Means each and every view of getting from the orthographic projection, so it will use the only two dimensions. So that's why option B will be correct here. Okay. The next 28. The hidden parts inside or the back side of the object with represented in orthographic projection are represented by which line? So already we discussed. So just it has been asked in the somewhat different way. Okay, because we are knowing. So whatever the hidden parts are there, so where this is shown by the dashed thin line. Okay, dashed means so it is also called as the dotted line also. And suppose something hidden portion is there, so like this we are showing it by using the dashed thin lines. Okay. So that's why the option C will be here correct. Okay, see next one. See next, it's 29th. Orthographic projection is the combination of two or more views on mutual perpendicular projections. It's correct. We are knowing that's means whatever the orthographic projection is there. So it gives the two or more views. Okay, like front view, top view, the side views. Okay, so that's why whatever this statement is there. So it's correct. So option A will be correct. Then 30th, the front view of an object is shown on which plane? So just before few MCQs we discussed. So whatever in case of first angle, so we are knowing. So whatever our front view is there, so we are showing on the vertical plane. Since see option A, profile plane. On the profile plane, so we are getting actual side view. So that's why it's not correct. On the vertical plane, so okay, on the vertical plane, we are showing our front view. So that's why B option will be correct. Horizontal plane, so it will not correct because on the horizontal planes we are showing the top view. Okay, in the parallel planes it's not correct. So option B is the correct here. Okay, let's see next one. Okay, so here the line perpendicular to HP and parallel to VP will have its front view. We can check out so possibilities. So what other line is there? So it is the perpendicular to HP and parallel to the VP. Means suppose we'll consider this line. Okay. And suppose we'll consider this as a vertical plane. Okay. And this as a horizontal plane. Okay. Means suppose here, so in this statement, what is mentioned? The line is perpendicular to HP. Means this line is there, so it is the perpendicular to HP and parallel to the VP. Okay, so like this condition is there of this line. Okay, then we'll have its front view. Then how will be its front view? So that has been asked. So first option, first is the point. Okay, means so this is the observer from this side. So we are going to observe. We'll get the point from the front view side. No, because point, when we'll get point, when you will observe from the top side, then only you will get the point. So A will not be correct. Then B, what is that? So what, how will you get front view? So the B, a line perpendicular to XY. It's correct because this is the VP and this is the line. If you will observe from this side, okay, then so you will get a line on the vertical plane. Okay, that will be so perpendicular to XY. Okay, yes, it will get the perpendicular to XY. So that's why here our option, so B will be the correct. Okay, so you'll get the line perpendicular to XY. And shortly we will draw here. Suppose this is the our reference axis. Okay, then according to this condition, so how will be the front view? So it will be like this. Okay, and how will be the top view? So let's suppose I'll consider this as a dash b dash front view, and its top view will be a comma b. Okay, as you will see, so whatever this line is there, so it is the perpendicular to the xy line. So that's why option A will be correct. Now next, a line perpendicular to HP and parallel to VP will have its front view. I'll see what is the condition. Line is perpendicular to HP. Okay, and the you see line perpendicular to HP and parallel to VP will have its front view. Okay, actually same condition is there, so only options are changed here. Okay, so same one you will see here, line perpendicular to HP and parallel to the VP, so we'll have its front view. Okay, so option A, line perpendicular to XY, line inclined to XY, line parallel to XY, none. So already we have seen. So in case of this line perpendicular to XY, so that's why here option A will be correct here. So what is this? Okay, so what are the front view will be in line perpendicular to the XY. Okay, so the option A will be correct here. And see now next one. Then next, a line perpendicular to HP and okay, a line perpendicular to HP and parallel to VP. Okay, yes, so line perpendicular to HP and parallel to VP will have its top view. The same conditions are there, so that we have seen in the previous two MCQs. But in the previous two MCQs, so they have been asked the how will be its front view. Okay, and that we got the perpendicular to XY, means line perpendicular to XY. Then here, so it has been asked, so how will be its top view? That already has been we have discussed. So how we are getting its top view? Okay, in this case, this is the condition, no? So line which is perpendicular to HP and with the parallel to VP means whatever is top view, in the top view means we'll get an point view. Okay, so here, so which option so will be correct, so that will check out. So point in HP, so this will be correct. Line perpendicular to XY is not, line parallel to XY not, sectional not. So option A will be there. Next, line perpendicular to VP and parallel to HP will have its front view. Is here, so suppose this is our vertical plane, okay, and this is the line, okay, this is the line which is perpendicular to the VP, okay, and it is the parallel to the HP. So this will be parallel to HP. Then how will be its front view? They have been asked. So it will check out. So so this is the line, so like this perpendicular to the VP, and this is the parallel to VP. This will observe from this side. From this side, observe it there. Okay. So observe from the front side. So what will able to see there? Okay, we'll see an point. Okay, because it will see from this side, so you will get an point. Okay, so that's why. So we'll draw here. So how will be? Uh, so this is the x1. Okay. So as I have told, so whatever the its front view, so we get a point. Okay, so here A dash, B dash. Okay, and whatever its top view is there. Okay, top view will get an line perpendicular to the xy. So here, so this will the A and the B. In this case, so like this condition will be there. Okay, means so front view will be point in the VP. So this is the option. Second option, line perpendicular to xy. It's not possible because line perpendicular to xy, so we'll get in the top view. In the front view, so what we'll get? We'll get a point. Line parallel to xy. So it's also not correct. Okay, so option A will be the correct here. We'll see now next one. Line perpendicular to VP and parallel to HP will have its top view. Okay, so same condition is there again, a line perpendicular to VP and the parallel to the HP. Okay, so same thing. So just we have seen in the last MCQ. Okay, so where we have seen, so whatever it's the front view, so how we're getting the point. Okay, so we're getting this front view. Okay, now so top view has been asked. Okay, so definitely we have seen that top view has been inclined, sorry, top view has been perpendicular to the xy. Is here a line perpendicular to xy, so this is the option correct. Then C, so it's not correct, so option B is the correct one. Then next, 36, a line parallel to both HP and VP. Okay, this is the condition. Suppose this is the vertical plane. Okay, if you see, is the line parallel to VP and is parallel to HP also. Okay, so in this case, so we'll have its front view. Its front view has been asked. So we'll draw in sketch here. So this is the XY. This here actually, if you see, so how will the, if this is the case, so this line is the parallel to the VP and HP. Then what are the front view? So we'll get a line parallel to the XY, and whatever stop is there, so that will also will get a parallel to the XY. It's like this our view will be there. So this is the front view, and this is the top view. Okay, so this is the A dash, and this is the B dash, so A. Okay, so front view will be, how will be? So that's the question. Line perpendicular to XY. It's not correct. A line parallel to XY is the correct. Option B will be. Okay. will line xy, it's not correct. So here option B is the correct line parallel to the xy. Okay, let's see next one. 37th, a line parallel to both HP and VP will have its top view. So just we have seen. Okay, if line is parallel to both VP and HP, so we are knowing that. So whatever is front view and top view will be parallel to the XY. So here, so option, we'll check out the option. So line perpendicular to XY, so it's not correct. Line parallel to XY, it's correct. Yes, here or option B will be correct. So it's not correct. Okay, so it's a simple one. The next, a line parallel to both HP and VP will have its true length. It's in the same case because now same case is there. This is the line. This is the VP. This is our line. Okay, it is parallel to the VP. It is parallel to the HP also. This if we observe from the front side, so we'll get the true length. Yes, we'll get the true length because if we observe from the front side, so we'll able to see the true length of this line. Okay, so we'll check out the statement of the problem. A line parallel to both VP and HP will have its true length. Okay, means if we observe from the front side, so also we are getting the true length. Okay, and if we observe from the top side, okay, then also you will able to see the true length. Okay, so that's why the option will check out A. So in the we are getting the true length in the front view, it's correct. We are getting the true length in the top view also, it's correct. So option C in front view as well as in top view. So option so C will be correct. Okay, because in both the views, that means in the front view and in the top view, in the both the views we are getting the true length. Okay, so that's why the option C will be correct. Okay, so we'll see next one. 39. Line perpendicular to HP and parallel to VP will have its true length. Line is perpendicular. Okay, so this is the line is the perpendicular to the HP and it is the parallel to the VP. Okay, so we'll have its true length. Okay, so we'll observe from this side. So from the front side, you will be able to see the true length. So we'll check out the options. Okay, option A in the front view. So we must get the true length of front view in the front view. So that's why option A will be correct. The top view that is not possible because in the top view we are getting the point view. In the front view as well as in the top view, not possible. So here option A is the correct. Next, line perpendicular to VP and parallel to HP. Okay, so this is the line. This is the VP. This is the line. This is the perpendicular to VP and the parallel to the HP. Will have its true length because now in this case, so in the front view will get the point view. Okay, and in the top you will get a line perpendicular to XY. Okay, and you will see here in this case, so in which view will get the true length? The top view, because if you observe from the top side, then and then you will be able to see the true length of the line. Okay, so here the option, so we'll check out in the front view, so we are not in the front view, we are getting the point view, so it's not correct. In the top view, so we'll get the true length, so option B will be correct here. So it's not correct. Okay, so B is the correct option. Then next, 41, a line inclined to HP and parallel to VP will have its front view. You'll see a line inclined to HP and the parallel to VP. This is the condition. Okay, yes, you will see. So I have inclined this line with respect to the VP. I'll use like this. Okay, this is the line. Okay, it's making angle with respect to the HP, and so it will the parallel to the VP. Okay, we'll have its front view. Okay, because in this case, so it will observe from the front side. Now here. So in this case, uh, so from this side, so I'm observing the as a front view. Okay, so in the front view, so what I able to see here, so whatever this line is there, okay, so it's making, or it is inclined with respect to the xy. Okay, and so whatever this line is there, so it's giving the true length also. Okay, we'll check out the option. A line inclined to HP and the parallel to VP will have its front view. Okay, so because in this case, so this is the line, so this is the inclined to VP and parallel to the inclined to HP and parallel to VP. Okay, in this case, uh, first option, front view will be of the shorter length, so it will not possible. Bigger length, so it will not possible. Equal length. Okay, so whatever the true length is there, so you will get in the front view. So option C will be correct here. Then 42, a line inclined to HP. Okay, inclined to HP and the parallel to VP will have its top view. Same case is there again. Is a line inclined to HP and the parallel to VP. Okay, will have its top view. Okay, so it will observe from the top view in this case. So it will get the apparent length of this line. Okay, so definitely it will not give the true length. Okay, so it will use the apparent length, so definitely it will of the shorter length as compared to its true length. So we'll check out the options. Okay, option A, so of the shorter length, so it's correct. It will give the shorter length, so bigger length not possible, equal length not possible. Okay, so option A will be correct in this case. Okay, next one, 43rd, a line inclined to HP and parallel to VP will have its top. We'll see now. Now in this case, so and is making angle with respect to HP. Okay, and the parallel to VP. So same case is there again. So it's inclined to HP and the parallel to VP. Okay, we'll have its top view. So options are there: A, perpendicular to XY. So we're knowing. So so what are the top views there? So it will give the apparent length. Okay, but so how it will be? It will be parallel to the XY. Okay, so we'll check out the options. Okay, so perpendicular to XY, it's not possible. Parallel to XY, it's correct. So option B will be correct here. So inclined to XY, it's not correct. Option B is the correct, because in this case, so it will see, it will observe from the top side, will get an apparent length that will parallel to XY. This how will be here, so I'll show you. Suppose this is the XY. Okay, and in this case, as it's making angle with respect to the HP, so that's why what are the front views we will get, so that will be, and front view will be an inclined to XY, so like this. And suppose we take this projection lines with them. Okay, so this is the top. Okay, this is the front view, so which gives the true length, and this is the top view, which gives the apparent length. That's the question. A line inclined to HP and parallel to will have its top view. Okay, So it's parallel to xy. Yes, so it is the parallel to xy. Next, line inclined to HP parallel to HP will have its front view. Same condition is there, but just ask its front view. So we're knowing now. So it's front view. It's the front view which is inclined to xy. Is the option correct? C. And the inclined to xy. Because if you see option A, it's not correct. It's not perpendicular to xy, not parallel to xy. Okay. So whatever its front view is there, so it is the inclined to xy because we are able to see here. Option C will be correct here. Okay. Next. Now, 45th, a line inclined to VP and parallel to HP. Now see, so just opposite to that condition is that a line inclined to VP. Okay. So in before some in the before MCQs, whatever we are seeing in that, so how the condition line inclined to VP. Okay. But here, so whatever this line is there, okay, now it's making angle. Suppose this is the this is the over VP. Okay. So it is now inclined with respect to the VP. Okay, just like this. Or I'll consider it like this now. This is our vertical plane. So with respect to the vertical plane, okay, so it's making angle. Okay, and it's parallel to HP now. Okay, means in this case, the top view will get an inclined to XY. Okay, and front view will get an parallel to XY, opposite to that. So I'll draw here that it's front view and top view. So this is the reference axis XY. As I told, so whatever it's front view, so it will be parallel to XY and top view will be inclined. So like this. A dash, B dash, A, B. Okay. So it's making angle with respect to the VP. Okay, so that's why top view will be the inclined. We'll see will be its front view. Okay, so whatever is front view, so it will able to it will see here. So this is our front view, and this is the top view. Okay, so whatever its top view is there, so it is going to show the its true length. Okay, but if you see it's the front view, it's giving the apparent length. That means it is giving the shorter length as compared to the true one. Okay, so that's why here option A will be correct of shorter length, not bigger or the equal length. Okay, so option A will be correct. Now 46, a line inclined to VP. Okay, and parallel to HP will have its top view. Same case is there. So just they have been asked how it's the top view. Okay, and already we have here its top view of shorter length. No, shorter, not shorter length. Bigger length. No, it's equal length. Oh, okay, that means it's showing the true length. So option C will be here correct. Okay, we'll see the next one. A line inclined to VP and parallel to HP. Okay, same. Just we have seen. So once again, I need to draw here. This is the reference axis. Okay, so whatever it's front view parallel to x1 is top view inclined to x1. So this is A dash, B dash, A, B. This is the front view. This is the top view. Okay, we'll see now. A line inclined to VP and parallel to HP will have its top view. We can able to see its top view is inclined to XY. So we'll see options perpendicular to XY. It's not correct. Parallel to xy, it's not correct because parallel to xy, its front view is there. Inclined to xy, it's correct. So, okay, so option C is the correct here. Okay, because its top view is inclined to xy. Now next 48th, a line inclined to VP and parallel to HP will have its front view. The same case is there again, line inclined to VP and parallel to HP will have its front view. We are knowing this, we will able to see here. So that's front view. It's parallel to XY. We'll see the check out the options. Perpendicular to XY, no. Parallel to XY, it's correct. Option B will be correct here. Inclined to XY, no. Inclined to XY, its top view is there. So here option D is here correct. Okay, so next, a line inclined to both HP and VP will have its front view. Okay, is the case. So where my, so we'll just draw here. Let's suppose this reference axis. Okay, this line is inclined to both HP and VP will have its front and top view. Is this the suppose this is the VP, this is the HP. Okay, so like this line is there. Okay, it's making angle with respect to both HP and VP. Okay, in this case, this is the like this line is there. So its front view also not showing its true length. So it will observe from the top view, its top view also not showing its true length. This is the line. This is the VP. This is the HP. Okay, and this is the line. So it's making angle with respect to HP, VP, and also making angle with respect to the HP. Okay, and if you observe, its front view also giving its apparent length, its top view also giving the apparent length. Okay, that means, so whatever the front view is there, so we'll get perpendicular to xy like this. So this A dash, B dash, A B. Okay, so in this case, so line is mentioned inclined to HP and VP. Okay, so here we have assumed it is parallel to VP. Accordingly, so we are getting its front view and top view perpendicular to XY. Okay, that means we consider this line as a profile line. Okay, as so it is only mentioned inclined to HP and VP. So accordingly, its front view and top view. So you will get it like this. Okay, means both are these apparent lengths are there, front view and top view. Okay, this will check out the option now. So what they have been asked, front view, true length, it's not showing true length. Shorter length, it's correct. It's showing apparent length means shorter length. So here option D is the correct. Okay, so here we'll see next one. A line inclined to both HP and VP will have its top view. Top view also not showing true length. Shorter length, correct. Option B is the correct here. Because it will observe its front top view also giving its apparent length. Okay, so here option B is the correct. Okay, actually we have covered the 50 MCQs. Okay, out of our 100 MCQs. So the remaining the 50 MCQs are there. So that we will see in our next video. Okay, so we will cover the remaining MCQs are in the next video. So that will be the part 2 will be there. Okay, so we'll stop here. Okay, and if anyone so haven't subscribed this our YouTube channel, then please subscribe it. Okay, so thank you.